Hi guys, in this video we're going to go through 2.5 where we're going to be graphing inequalities. So when it's in slope-intercept form, well actually we'll start here. If it's a less than or greater than symbol without the or equal to, we're going to use a dashed line. If it is less than or equal to or greater than or equal to, we're going to use a solid line. Okay, and then when it's in slope-intercept form, if it is less than or equal to, we're going to shade above the line. And if it's, and of course I wrote that backwards. If it's less than, excuse me, so y is less than or y is less than or equal to, we are going to shade below. And if it's y is greater than or equal to, we're going to shade above. Okay, so we're going to go ahead and use those ideas here and we're going to graph. So if it's in slope-intercept form, we're going to graph the same way we always do. Start with a y-intercept and then use the slope to get another point. So I have y is less than x plus 2. So my y-intercept here is 2. And my slope is 1, so I'm going to go up 1 and over 1. And you can keep that pattern going to get a pretty accurate line. This is going to be a dashed line because it's less than, not less than, or equal to. So I'm going to do a dashed line. Okay, and then I need to know, am I shading above or below? So because it's in slope-intercept form, if it is y is less than, we're going to shade below the line. And that's our graph. So very similar to graphing lines, the only two pieces that we need to worry about are the dashed versus solid line and then the shading. Okay, so this time we have, again, slope-intercept form. So my y-intercept is 3. So I'm going to go up to positive 3. And my slope is negative 2, so negative 2 over 1. So I'm going down 2 and over 1. And again, you can get a couple points in here to keep your line accurate if you want. Okay, this time it's going to be a solid line because it has the or equal to. So connect with a solid line. And then we are going to shade above this time because it is greater than or equal to this line. Okay, now we can also do this with our kind of special cases, the horizontal and vertical lines. So the vertical line is always x equals. So if it's less than or equal to, it's going to be a solid line, but it's going to be a solid vertical line through negative 3 because it's x. So we're going to draw a vertical line through x equaling negative 3. It would be dashed if it was less than or just less than, not less than or equal to. Now this is x is less than, so I have to think about where are my x values less than negative 3, to the left or to the right. This one's not really above or below because my vertical line's continuing forever, both directions vertically. So I have to think left and right. So values are less than negative 3 to the left. So this is the only time I really have to worry about left and right is when it's x and a vertical line. Y is greater than 2. This is going to be a horizontal line through 2. It's going to be dashed. Sorry, kind of hard to see. Probably I'm going to make those a little darker. Okay, and it's y is greater than. So greater than is above. Okay, so we're going to do something called testing points. We don't have to do this when it's in slope-intercept form. So kind of like we just did, we didn't do any testing of points. So you don't necessarily know what this means just yet. We're going to do an example. But this is when we do have to test points. If an inequality is in standard form, remember that's ax plus by and then c, and then there's going to be some sort of inequality symbol in here, less than, greater than, less than or equal to, greater than or equal to. We can either rewrite the equation in slope-intercept form and then graph like we just did, or we can graph using intercepts and test a point. So I'm going to show that to you guys so we can look at what that looks like. Sorry, my formatting is a little funky on here, you guys, so bear with me. Number 5, I'm going to graph using intercepts. So remember that's taking turns plugging in 0 for x and y. So I'm going to plug in 0 for x. So if I plug in 0 for x, 3x is gone, and I have negative 4y equals 12. Okay, divide by negative 4, and I'm treating this as an equal sign, you guys, just because I want to know what does y equal when x is 0. Okay, so divide, so I get y equals -3. So that means my y-intercept is 0, -3. Okay, so I'm going to go ahead and put that point on the graph. 0, -3. Now I'm going to plug in 0 for y, so that means the minus 4y is gone. So I have 3x equals 12, divide by 3, so x equals 4. So that means my x-intercept is at 4, 0. So 4, 0, point here, and then I'm going to connect. So this is where I have to worry about solid line versus dashed line. So my solid line is going to be used because it's or equal to. So now, because y isn't by itself, I don't know is y less than this line or greater than. So this is where I'm going to test a point. Almost always, you guys, test 0, 0 if you can, because zeros are easy to plug in. So I'm going to plug in 0, 0. So here's what testing a point looks like. We're going to plug in these values for x and y, and I'm going to see, does it make the inequality true? If it does, wherever this point is, that's where I need to shade. If it's not true, then I'm going to shade the opposite. So we're going to say, duh, is 3 times 0 minus 4 times 0, is that less than or equal to 12? Well, I just get 0 here. 0 is less than or equal to 12, so that means 0, 0 is in the shaded region. So here's 0, 0, so in the shaded region is going to be up here. If we got something that was untrue, like if I got 13 is less than or equal to 12, that means that point is not a solution, so it's not in the shaded region. So all of these points in this region, if I plug in any of these points in for x and y, they will give me something less than or equal to 12. Okay, now we're going to try 6. So I'm going to graph using intercepts as well, but I need to get it in standard form. So I want the x and y piece together but by itself, so I'm going to divide both sides by -3. Remember, dividing by a negative flips the inequality symbol, so I'm going to have -10x plus 2y is less than or equal to -4. So I'm going to go ahead and plug in zeros, so 0 for x, that goes away. Oh, sorry, I'm just going to do equals here. So y is -2, so y-intercept at -2. Plug in 0 for x. Plug in 0 for y, we already did x, so I get -10x equals -4, divide by -10, so I get x is equal to 2/5 or 0.4. Okay, so this one is in here. Okay, so we graph. This one's again a solid line because it's or equal to. Okay, now I want to know, do I shade above or below? So I'm going to test the point. Again, I'm just going to test 0, 0. So I'm just going to plug it back into the original here. So I have -3 times -10 times 0 plus 2 times 0. And then I'm asking, is that greater than or equal to 12? Okay, so do my math over here. So here I get 0 plus 0 times -3 is 0. 0 is less than or equal to 12. No, it's not. So that means 0, 0 is not in the solution, so it's not in the shaded region. So I'm going to shade the side opposite of where that point is. Okay. Okay, I'm going to do 7. Again, my formatting is kind of funky. Sorry here, guys. So I'm going to go ahead and do 7. It's going to be really similar. I want to get the x and y component alone, so I'm going to multiply both sides by 4/3. So I get 8x minus 2y is greater than 8. Okay, so intercepts, so plug in 0 for x, so I get -2y equals 8. So y-intercept is -4. Okay, plug in 0 for y. So my x-intercept is +1. Connect. This one is a dashed line. Because it's just a greater than symbol, not a greater than or equal to. Okay, test a point. Again, I'm going to choose 0, 0. So I'm plugging in to the original equation, 0 for x and 0 for y. Okay, so I get 0 here, and 3/4 times 0 is still 0. 0 is not greater than 6, so that means 0, 0 is not in the solutions. So we're going to shade the side opposite of where 0, 0 is. Crossed my line a little there. Okay, so that is how you can graph using intercepts and just testing a point. Okay, this one we need to write an inequality first before we can graph. So backpacks sell for $35 and tote bags sell for $20. Total sales for 1 week must be $2,000 for the company to break even. Graph to show how much of each must be sold for the company to make a profit. So I'm gonna let's see, I'm gonna do B for backpacks. I'm identifying, let's do X and Y because we're graphing. So I'm gonna do X for backpacks and Y for totes. Okay, so my equation, obviously the company's happy the more money they make, so the minimum is $2,000. So we are selling $35 per backpack, so 35X, plus the $20 per tote bag, and we want it to be at least 2,000. So we want it to be greater than 2,000 or equal to 2,000. Okay, so there's my inequality. I'm going to graph using intercepts, so I'm going to go ahead and plug in zeros. So I've got 0 for y, so I've got 35, x equals 2,000, x equals, so if I do, oops, sorry, hit my camera there. Okay, so if I do 2,000 divided by 35, we get 57.1. Okay, and if I do 0 for x now, and 2,000 divided by 20 is 100. That'd be 1,000 actually. 100. Okay, so obviously I have very big numbers here, you guys. So I'm gonna make, how about let's make these each go by tens. So I'm gonna just interval by tens. So instead of 10 here, this is 100. Okay, so 10, 20, 40, 60, 80, 100. Okay, so my y-intercept is 100. So if these are going by tens, there's my y-intercept. My x-intercept is 57.1, so just under 60. Okay, and I'm going to do a solid line because it's greater than or equal to. And now I just need to show, am I shading above or below this line? So I'm going to test a point. So again, I always like to plug in 0. And we can see if I plug in 0 here, 0 plus 0 is not greater than 2,000. So that means this is not in the solution set, so I got to shade above the line. So any combination of totes and backpacks in this region or on this line would get them a minimum of $2,000, if not more. All right, that's it for this video, guys. Thanks for watching.